So how did everybody do for 7.3? So hopefully that went fairly well for you. So 7.4, we're going to talk about percent problems and compound interest. So again, percents come up all the time. You see percents every day, really, whether you're buying something, whether you have a credit card, whether you have money in a bank. So percents are all around. So percent just means per 100. So with that in mind, like another way to think of 50% would be as the fraction 50 over 100 or as a decimal 0.5. So that's going to be a lot of what we're going to do today is move things from percents to decimals and stuff. So another thing to recognize in this section, whenever you see the word of's always going to be multiplication. All right. So if we look at the first example, if I had $30 and I have to give you 50% of what I have, how much do I give you? So what we're doing is we're taking 30 and multiplying it by 50% or 0.50. And if you just multiply that out, that's going to give us $15, which you probably knew how to do anyway. So that looks good. So now what we want to do is we want to write a decimal as a percent. So the main thing we want to do is we want to move the decimal point 2 places to the right and add the percent sign. So for example, in the first problem, 0.675, we want to move this 2 places to the right. So that's going to give us 67.5, and then we just add the percent sign to it. All right, so I'll leave the rest of 1 for you guys to do. So for 2, what we want to do is work backwards, write the percent as a decimal. So what we want to do is the opposite operation. So in this case, we want to move the decimal 2 places to the left and take away the percent sign. So in this case, notice there's no decimals. So that means we need to put 1 in. So there is technically a decimal after the 3. We just don't write it if there's no other numbers after the decimal. And so in this case, we want to move this to the left. So 1, 2. So that gives us 1.63, and then remove the percent sign. So we end up with just 1.63 as our answer. All right, is that okay with everybody? All right, so for 3, we want to write this percent as a fraction. So what we want to do is we want to use that idea that percent equals something over 100. So what we want to do is take away the percent and turn this into a fraction. So this is going to become 16 per 100 or over 100. And then you just simplify from there. So in this case, I notice a 4 goes into the top and the bottom, which gives me 4 over 25. And 4 over 25 is as far as I can simplify that, so I'm done. All right. So finally, the last thing we want to do is write a fraction as a percent. So in this case, what we want to do is we want to divide first to turn this into a decimal. And then use what we learned above from turning a decimal into a percent to do that. So then turn into a percent. So this has kind of 2 steps. So let's first divide 1 over 8. So we get 8 on the outside, 1 on the inside. So 8 goes into 1 or 10 one time. Bring down our 0. So 8 goes into 20 2 times. So bring our 4 down, bring our 0 down, and then 8 goes into 45 times. So it gives us a 0. So our decimal in this case, so 1 over 8, is the same thing as 0.125. Now to turn this into a percentage, we want to move our decimal 2 places to the right and then add our percent sign. All right, so hopefully that's good with everybody. So again, at this point, make sure you go back, pause the video, go practice all those ones for 1, 2, 3, and 4. So otherwise, what we want to do is move into, these are the problems that were on the gateway exam that we had talked about, these is and of problems. So the way to remember these are always going to be of this form, is over of equals percent over 100. So all we're trying to do is find the missing spot, fill it in, and then solve for it. So like in this case, we've got what is 70% of 400. So what we know is the is the missing part. We've got the percent, and we've got the of. So what we want to do is fill this out. So x will go in the is position. Of our 400 goes in the of position. The 70 goes in the 70 position. And then it's always just over 100. So again, what we want to do is cross multiply these guys. So 100x equals 28,123. Divide both sides by 100. So this gives us x equals 280 in this case. So again, the rest of 5 are exactly the same way. Set it up as is over of equals percent over 100, and you'll be fine. So I'll leave those for you guys to practice. So 6, A, B, and C are all using similar type methods to is and of, even though it's not exactly spelled out the same way. There are other ways you can do it, but if we look at 6A, John bought a house for $215,000. If a 20% down payment was required, how much was the down payment? So in this case, so this is actually going to be our of our problem. This is obviously going to be our percent. And how much was the down payment is our is. So if we set this up as an is and of problem, we're going to get x over 215,000 equals 20 over 100. So again, cross multiply these guys. We're going to get 100x equals 430. And now divide both sides by 100. So again, these zeros just cancel out. So we end up with x equals $4,300 would be our down payment. Now another way you could do this is just multiply 0.20 times 215,000 and you'll get the exact same thing. So I'll leave it up to you guys, whichever way you want to do. All right, so I'll let you finish off 6, B, and C. And so finally with 7, we're starting to get into our compound interest formula. So you may have seen this before, you may have not, but so let me explain some of the parts to it. So the P in this case is what's called the principal. So it's the amount that you borrow, or it's the amount that is in the bank at any given time. The R is the interest rate, always as a decimal. And then finally, T is the time in years. So when you're looking through a problem, all that stuff's going to be given, so it's just a matter of going through and identifying what's what. So if we look at 7A, if you keep money in a savings account at a bank, the bank pays you interest at a fixed rate. So suppose you invest $6,000 for a year at an annual interest rate of 5%. How much is your investment worth at the end of the year? So in this case, the 6,000 is going to be our principal. Our time is going to be the 1 year. And our interest rate is going to be the 5%, but again, as a decimal, it's going to be 0.05. So again, plugging everything into the formula, we're going to get 6,000, 1 plus 0.05, all raised to the 1. So now it's just a matter of typing this into the calculator. So we get 6,000, 1.05 raised to the 1 is really just 1.05. So we're multiplying 6,000 times 1.05, and that gives us $6,300. So what that means is, so there's $6,300 total in the bank. So that extra, anything over the 6,000 is our interest in that case. So if it would ask, the interest that we earned is the $300, or you take 6,300 minus 6,000. All right, so B, I'm going to leave B and C for you. So in this case, what they're doing is just kind of taking the interest from the amount of money that we had at the year one and calculating it the same way. So the main thing to remember here is we don't go back and use the same 6,000. Now we're going to use the 6,300 as our initial principal. Our time is still 1, and our interest rate is still 0.05 in this case. And so do B and C. And then finally, we've got our full-blown compound interest formula, which has added a new letter to the mix, an N. So in this case, so a lot of the stuff is still the same. So again, P is still the principal. The R is still the interest rate, again, as a decimal. The T is still the time in years. So what we've added in are these two N's. And so what that is, it's the number of compoundings, which is where the word comes from. And so, but what's compounding mean? So it's the number of times the interest is calculated. So if we go through, the way we want to think about this is, like if, for example, the problem above, N was technically 1, even though we didn't have it in there. And so what was happening is the interest was compounded one time a year. So let's make a little chart here real quick. So we can see the most common compoundings that there are. So again, we already did N equals 1, which would usually be referred to as annual. So in the problem, you'll see it's compounded annually, then that means N is going to be 1. If you see that it's compounded semi-annually, that means that N would equal 2. So if it were quarterly, N would equal 4. Monthly means N would equal 12. Weekly means N would equal 52. And then finally, daily would mean N was equal to 365. So write that down, keep it somewhere, so that way when you're doing these problems, you'll know exactly what the compoundings are. So otherwise, let's jump right in and try number 8. So suppose our credit card charges 18% interest compounded monthly on unpaid balances. If your credit card was maxed out at its limit of $2,500 and you were unable to make any payments for 2 years, and assuming no penalties and how much debt, how much do you still owe the credit card at the end of the 2 years? So again, let's write down all the main stuff that we're interested in. So the amount that we owe the bank or the credit card originally is $2,500. Our interest rate is the 18%, or in decimal form 0.18. The number of compounding, since it's monthly, is going to be 12. And the time is 2 years. So now to fill everything out in our formula, we're going to get 2,500, 1 plus 0.18, our interest rate, all over our number of compoundings, 12, all raised to the 12 times 2. All right, so with this is actually where most people end up tripping up, is trying to actually type this in the calculator. So if you've got a fancy TI calculator, actually type it in exactly the way it's written, same number of parentheses, same everything, don't add anything, you'll always get the right answer. If you're using a phone calculator that doesn't have parentheses or things like that, what you may have to do is actually break this down into smaller steps. So I'm going to show you how to do it in smaller steps, and then if you have questions, just let me know. So in this case, what we want to do is start with the inside, plug that into our calculator first. So 1 plus 0.18 divided by 12 gives me 1.015. And then I'm going to go ahead and multiply these two together just to make it a little bit easier. So 12 times 2 is 24. So now what we want to do is do the exponent next. So do 1.015 raised to the 24. And so we should end up with some number like 1.429, dot, 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 some other stuff. So at this point, do not erase that out of your calculator's memory, because we want to keep as many decimal places as possible. We don't want to round until the very end. So what we want to do next is take that full number and just go ahead and multiply it by the 2500. And in this case, we end up with 3573.757. So since this is money, we're always going to round this to 2 decimal places. So that's why I added the extra 7 at the end to see whether I want to keep that a 5 or move it up to a 6. But since it's 7 is bigger than 5, we want to move this guy up to a 6. So our final answer would be 3,573.76. So notice we started off owing the credit card $2,500, and now we owe pretty much over $1,000 more. So you can see how interest can actually add up really, really fast, and that's why you have to be careful with credit cards and debts and things like that. So, all right, so the last page is just a bunch of practice problems trying to move things from fractions to decimals and blah, 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 blah. So again, I'll leave that for you guys to practice. So at this point, we've done everything for the whole semester, so good job, everybody. Hang in there. If you have any questions, let me know.